Hey everyone, welcome back to JFG Academy YouTube channel. So today our topic is this is Igneous petrology lecture 2. So in this lecture we are going to discuss about the magma. Okay, so what is the magma? What is the definition of magma? So magma is a hot fluid or semi-fluid within the earth from which igneous rocks are formed on cooling. So it is a very hot fluid, or it is in a semi-fluid state within the earth's interior which form igneous rocks. So these are the basically building materials of igneous rocks. Okay, so which are formed on cooling. From which igneous rocks are formed on cooling. So here I have written magma minus volatile is equal to lava. So when volatile escape from the magma, it will give rise to lava. So lava, when the magma comes to the earth's surface, the volatile matter like a CO2, H2O and all gases escape from the magma, and it we know this as lava. Okay, so third important point is that huge amount of magma comes from Earth's interior. Okay, huge amount of magma comes from Earth's interior during a volcanism or Miocene ridges. Okay, so evidence of magmas are first volcanoes. Magma comes out or lava comes out from volcanoes. Miocene ridge, that is divergent plate boundary, and magma comes out from Miocene ridge. And third one is all igneous rocks that crystallize before. So all igneous rock that are crystallized before is also the evidence of magma. Okay. So from this, in your mind, a question may come. So the question may be, where does this magma comes from? Okay, so from where the magma comes from, where it originates, this is obvious question comes in your mind. So some rocks of crust or mantle melt to produce magma. This is obvious. Some part of crust or mantle may be melt to produce magma. Both crust and mantle can melt. It has the capability to melt to produce magma. But the problem is, most of the crust and mantle can melt to produce magma. Most of the mantle and crust are solid, not in liquid state. Okay, so most of the mantle we know and crust are in solid state, not in liquid state. Thus, magma can especially form in particular region. Okay, so when the temperature is very high, where the pressure is very low, where the temperature is very high, that region, that particular place, the magma can generate. Okay. So now another important point is that factors that affect melting. So what are the different factors that can affect the melting of a rock? So the answer is, there are two factors that can affect the melting of a rock. I have told earlier, pressure and temperature. So here pressure is a function of depth. I have shown this illustration. This is the boundary between mantle and core, and here pressure is in GPa, gigapascal, 100, 200, 300, 400 GPa, and this is the depth, increasing depth in kilometer, 1000, 2000, 3000, 4000, 5000, 6000 kilometer. So look here, the pressure is gradually increasing from here to here, and then it is quite decreasing from here to here, from below the core boundary. So in the mantle, the pressure is increasing. So what will happen when the pressure will increase? This is the pressure is increasing. Here also the pressure is quite decreasing. So you know, the pressure is the force per unit area, but the pressure, greater the pressure, it will prevent the melting despite at high temperature. So when the temperature is high, melting will not, pressure prevents melting. The pressure will prevent melting despite high temperature, but when the temperature is low, it will melt the rock. So pressure within the earth is called confining pressure or lithostatic pressure, which is similar to hydrostatic pressure. Now in the gate point of view, our important thing is that how to convert the unit of pressure. So numerical questions asked from this. So converting the units is also an important part in the gate perspective. Now look here, this is the unit conversion. 1 Pascal will be equal to 1 Newton per 1 meter square. 1 Newton is equal to 1 kg per meter, 1 kg meter s to the power minus 2 into this 1 by meter square. So 1 Pascal will be equal to 1 kg per meter into s to the power minus 2. 1 megapascal, mega means 10 to the power 6 Pascal and giga means 10 to the power 9 Pascal. Okay, so 1 megapascal will be equal to 10 to the power 6 Pascal and 1 gigapascal will be equal to 10 to the power 9 Pascal. So note down this. This is also important in numerical point of view. Okay. Now 1 kilobar is equal to 1000 bar, but 1000 bar is equal to 10 to the power 8 Pascal. 10 to the power 8 Pascal is equal to 0.1 gigapascal. Now 1 kilobar is at 3.3 kilometer depth. On increasing the pressure, melting point of the material also increases. So now second thing is temperature as a function of depth. So look this illustration. This is temperature and this is the crust and lithosphere, and this is the boundary between the convecting mantle and crust and lithosphere. So this is the curve. Here the temperature is increasing, then the temperature is slightly decreasing, and then it is increasing up to the core. This is the core. So look, if temperature increases at a particular pressure, then the melting will start. So when we fix the pressure and increase the temperature, then obvious thing is that the melting will start. The melting will begin. Now how melting of a rock occur? Look this illustration. So this is a curve. This is solidus. So all those things which are here are solid, and this is liquidus curve. So all the things here liquid and non-liquid here, and this is the bound. This is the middle region. So here the mixture of solid and liquid. So this is the point A is the melting point. So when this liquidus curve touches this temperature, this melting point temperature, the melting will start, because this is the melting point of the rock. Here the melting will start. So this entire curve will move in this way, so that the melting will occur. Okay. Now if the substance is pure, then it will have only one melting point. So this is basically depth of pressure, and this is the temperature. But if the thing is a mixture of minerals, it will have more than one melting point. So basically rock is a mixture of minerals. So if this is a rock, there are different minerals A, B, C, X, Y, Z. So all this one have a melting point, this one have another melting point, this one have another melting point, this one have another melting point, this one has a different melting point, and this one has a different melting point. So the rock is a mixture of minerals. So the rock will show a range of melting point. So basically mantle will melt to produce the crust. So this is the end of the lecture. We will continue these things in our preceding lecture. So if you have not subscribed our channel, subscribe it. Other faculties are also going to join. So stay tuned with the channel, and if you have not joined our Telegram channel, join our Telegram channel. I have given so many quiz questions there. so that it will be very helpful for you. Now I am giving some quiz here, so do the quizzes and write it down in my comment box, only the answer of the quiz questions. Okay. So these are 5 quiz questions for you. This is the homework for you. Okay. So first one is, what are the 8 major elements in the crust in increasing order or in decreasing order? Decreasing order. Second question is, combining oxide give rise to dash. Temperature range of igneous rocks dash to dash. Fourth question is, what is an ophiolite sequence, and fifth question is, composition of mantle is dash. Okay. So now, thank you for your patience. Note down these questions. Thank you.